Atul, Ramkrishna. Am I audible?
Yeah, yes, you are audible.
Okay. Good evening.
Good evening, all of you.
Yeah. Yes, Atul, you want to start?
What?
You want to start discussion?
Not right now. I did not have any. In the meeting, if I should have, I will.
Okay. In group, I think you started some issues, no? That post. You have some.
I did not found any solution because everything is fixed by client. So I increased to cell thickness. That was my last goal.
Okay. So you increase the shell thickness and your.
I increased the cell thickness. But in Monday, I will try because someone stand in evening that we can use 90% of it. If it is failure in test condition, I will also try this on Monday.
Okay. So you are changing to 90%, then the thickness may reduce and you will use that one.
Thickness will be reduced if in test condition.
Okay. Okay.
Hi Atul. This is Gokul here. Actually, I only gave that idea to consider 90% of yield in your allowable stress.
Yeah, so thank you. But somewhere
Actually,
as a tactic.
what is the scenario? I'll explain. As per ASME section division 2, class number I believe part 4. 4.18 or 15 something. 15.
4.18.
In that there will be one condition for horn stress. If you go to the equation, you can find that, and there will be acceptance. They will give some acceptance criteria. But what is the thing is, when you are seeing the operating condition, the allowable stress it will take as from the software, like from the code. Okay, but when you are considering test condition, your acceptance criteria of actual stress will be more than the operating condition.
90% as per division first and 95% as per division 2.
Yeah, but pvelite will not take 90% of yield.
Yeah.
Yeah, so that is the case. Your horn stress is failing. I also personally faced this problem when I discussed with AI. What authorized inspectors they are saying is in hydro condition by defaultly it will consider. But my client they didn't accept. So what we did is. Yeah, what we did in that case to close the matter is we considered we have removed saddle calculation from the main calculation, and we have submitted separate calculation for saddle considering 90% of yield in the allowables.
Manual calculation.
No, software calculation only. From the pvelite, we have removed saddle calculation in the operating condition. Okay.
Okay.
Yeah, and we have performed separate calculation by considering 90% of yield.
Got it.
And the client also accepted. You will not believe that. See, my vessel diameter was 8.2 meter, and it is SS.
Okay. I will try it. Thank you.
Yeah, it will definitely work it out, and authorized inspector accepted that.
Yeah, he will.
This is the advice given by authorized inspector.
Okay.
Exactly, I will tell you the case. Actually, there was some very huge discussion and they have discussed. Our HSB is my authorized authorized inspector team, and they have taken to the US team, and from the US team, those who are supporting for writing codes, from them they have got this advice.
Because it is their domestic code.
See, I will let you. Just I have opened the code. Wait, let me see the code. 0.18.15, right? Do you remember the class?
No, I'm searching.
Actually, I have opened in my mobile. It is 4.15. It is 402.
Is it possible you to share the screen so others can also see?
No, actually, I'm opening in mobile. No.
4.15 designed for support
Yeah,
and detachment.
4.15. Yeah, it's not 4.18.
4.15 designed for supports and detachment.
Yeah, wait, let me.
So you want to guide something on 4.18 to Atul, or how it is?
Actually, if
4.15.
you, I think it is your flat cover acceptance criteria or your absolute value sigma phi shall not exceed 1.25 of, yeah, exactly. Yeah, this is the one. See, actually, if you see the equation 4.15.15, this is for this is correct, no? Longer to not sure acceptance. Sigma phi is the Horn stress. Yeah.
Yeah,
See,
even
there
if
are,
it
what is the addition? It is to an elliptical, no?
yeah, elliptical.
Yeah. See, if you see equation number 4.15.15, your sigma, your acceptance criteria for sigma phi, it should be 1.25 of SH. Okay. The SH is nothing but the allowable stress on the dish end.
Atul, you are on
Yeah,
mute. Yeah.
got it.
Yeah, yeah, allowable stress as a descent. When you see the operating condition, your allowable stress will be as per part two.
Part
It,
2.
it will take 1.25 of SH. But in test condition, if you see means it will not taken in the account. It will not consider in pvelite.
No, it will not consider in pvelite.
Yeah, in test condition, it will consider the acceptance criteria as per this condition. Sorry, in operating condition, it will go with respect to this code, this class. But in test condition, it will not go. What is my client said is like they have finalized the saddle location actually. So they don't want to increase or decrease the saddle distance.
Yeah, foundation is fixed.
Yeah, foundation. So there is to move here. See, it is a matter of 100 to 200 moving here and there. This will resolve the matter.
Yeah.
Okay, if you like, and if you play with the saddle and gear plate orientation and with respect to the TL distance, this will play the major role. Your hand stress governs. It's nothing but it's close to your distance.
Yeah.
When there is when there is a different shape, your hand stress generates. So different shape is nothing but your distance is closer.
Yeah, this method is nice one. I will try it in Monday.
Yeah. So
Because
in
there
this
is
case, this will
there is no
work it out. Yeah.
yeah, because there is not too much selling, only 50 kg per centimeter
See,
square
instead
molded.
of increasing your thickness unnecessarily, thickness increasing is a better one solution. But you can try
Yeah,
with
but
this
it is
method if
last
client
option.
accepts.
Thickness is last option only.
Yeah, last option. Unnecessary weight you will increase. You will get
Yeah,
increase. Depend your support will increase. See, if you
because
consider this, no, if you consider like something like 90% of yield as allowable, my saddle thickness got something like 30-40% like base plate thickness got 30-40% lesser than actual thickness.
absolutely.
Yeah, my saddle thickness previously was 64 or 65 and I got up to 40 like 48
Hmm. All things depends on the level of stress.
Yeah, all of stress. Yeah, if you play this, so definitely it will work out. And it is code division one, code stamp job, and it is stamped also.
Our also in Houston.
Now, what I'm saying is this has happened in the division one code stamp job. and it is witnessed and approved by authorized inspector teams also.
Because division 2 is also na ASME code, and division first don't do support detailing.
Come again?
Division first is not division first don't do detail engineering but support. That's why we can use part division 2.
See, saddle is a non-pressure part, and there will no. We can use Denismos also. We can use zig method. We can use it depends on first of all client requirement, and it depends on our good engineering practice.
Sure.
Yeah. So there is no code restriction and nothing is there in division 1.
Yeah. This is totally as support.
Yeah, got total support, and it is our this is mostly it will run through zig method. So if in easier way, as code ASME is already generated this value, so we are following division 2.
Yeah, sure.
Yeah, mostly why? Because we are following the division 2 is to reduce the consent thickness. Yeah, nothing else. Even in zig method, you will get a higher thickness compared to division 2 if you are calculating the saddles.
Yeah, because if we select as per division 2, thickness goes higher and stresses go higher also.
Yeah. What is the thing is, if you are going to division, if zig method calculation, your allowable stress will take from division 1. If you go to division 2, automatically your allowable stress taken from division 2. So that's the difference. Thickness will also plays a major role.
Raj Gokul?
Try and let me know. It will work it out. No issues.
Yeah, I will.
Raj Gokul, can you just tell us, because others also understand, what actually issue is and what you are suggesting solution?
See, actually, what happens, in when you are designing a saddle, so there is one by default thing we will consider that a dimension. In pvelite, if you are defining a dimension,
Okay.
That is it should be 0.5 times of your radius as per Denismos.
Means descend to your saddle center. It's
TL to your saddle center.
yeah. Okay.
Which are nearby, left side or right side.
Okay.
So your concept is 0.5 times of your radius.
Okay. It's that's a thumb rule. It's not anywhere there. It's thumb rule. We follows that 0.2 or 0.5.
Come again, sir.
It's a thumb rule, no? It's not defined
Yeah, it is given. It is clearly stated in Denismos.
Okay, it's Denismos, not in the code. It is given in the Denismos.
No, our code says. Yeah, no, sir. Code it is not defining anything related to dimensioning, sir.
Okay. So Denismos given
what,
this one.
What code is saying?
This is recommended by LP. Jig method, I think.
Yeah.
Jig
No,
method.
in Denismos also it is there. It is in Denismos also it is there.
I think Denismos adopts jig method. So I think fair to say it is jig will be jig method.
Okay.
Yeah.
Okay.
Actually, where the horn stresses generates, if there is any different shape generates.
Okay.
See, your saddle is located in the shell.
Okay.
So your different shape is like the shell.
Okay.
So if it is closer to you, if your saddle is closer to your generate, then horn stress will generate.
Okay.
So if there is that is sigma 5. Basically, the horn stress is it is called sigma 5, which is stated in division 2, and the acceptance criteria is also clearly stated in part 4.15.
Okay. So
it is there. It is there in zig. It is there in all the codes. Zig method also it is there. It is PD 5555 is also there. In EN standard is also there. In EN you can see for 13445 part 3.
It's a pressure vessel standard.
Yeah.
Okay.
Yeah, pressure vessel standard. Yeah, you can find in European standards also.
Okay. So
same acceptance criteria. But what is the bad thing we are we are facing is mostly we are using pvelite, no?
Yeah.
So allowable stress in operating condition, it is taking the acceptance criteria 1.25 times of SH.
Okay. Mm-hmm.
So SH is nothing but the allowable stress of your decision head.
Okay. Mm-hmm.
But when you in operating condition it will take correct, but in test condition there is some contradiction.
90%.
Many people are saying by default your allowable stress is 90% of yield.
Yeah.
So this acceptance criteria is not required. 1.25 times of allowable stress, which will increase your, which will cross your yield limit.
Mm-hmm. Okay. Mm.
See, for example, if you're taking carbon steel material, your allowable stress is 138 mm. Oh, sorry, 138 megapascal.
Okay.
Okay, and your yield will be something like 250 or something.
Mm-hmm. Okay.
When you are designing hydro test, your 1.25 times of SH will be something like 184 or something.
Okay. Mm-hmm.
But when you are considering allowable stress as 90% of yield in test condition,
Mm-hmm.
so then it will cross your yield point.
Mm-hmm. Okay. Okay.
Understood? No.
Yeah.
So you are in operating condition. SH is as per code.
Yeah.
So that is
In test
bug in
condition,
pvelite.
SH is equal to
That is a mistake by pvelite.
See, we already fought with pvelite, but pvelite is saying they also like couldn't understand what is our instance, and the authorized inspector teams also couldn't understand what is our query.
No, it is common sense, no? So in code, nowhere it will be allowed more than 90% of yield. I mean, it cannot go beyond yield. That is the
Beyond yield. Yeah, what is my I told my understanding.
yes.
Like in operating condition, your SH will be as per code, and in test condition, your SH will be 90% of yield.
Yes.
When we are calculating 1.25 times of SH, it is crossing the yield point.
Yeah. Value of
Then
that.
it is not acceptable.
It's crossing it. There is no value now. Yeah. It's crossing it. Yeah.
Yeah, it's crossing the yield point, so then it is not acceptable. So pvelite should take care of this. Like that, pvelite should suggest, or someone should suggest like that. We told.
Mm-hmm. Okay. Okay.
Then nothing happened. So we came up with the option, as this is a non-pressure part. We mentioned that we will consider allowable stress itself 194, and yield is also like 194. We will limit the yield.
Okay. Okay. So you manually
Then
edited and.
manually we calculated, and 194 megapascal it comes, like we considered everything as 184. This is SS, like I am talking about. Our vessel is SS.
Okay. Okay. Mm-hmm. Supports also with SS.
Yeah. And they are like what we stated, they couldn't understand, and they are not accepting also.
Because they believe pvelite may be the correct software and giving the right answers.
Yeah.
Maybe that not understand.
Exactly.
Okay. Okay. So.
Generally, your horn stress doesn't play a major role. When the horn stress will play, if there is your diameter is higher and your thickness is lesser, no. In that time only this horn stress will comes under the picture. Mostly it.
Yeah, coming to can we go to another topic?
Yeah, we can.
Yeah, so just to come this pvelite, earlier it used to calculate the anchor bolts for the frictional forces of the sliding saddle. Later they removed it. I don't know why. Anybody having?
No, actually they have. I believe that they given one explanation why they removed.
Yeah.
If I'm not wrong, before 1 year, I think before 1 year or two.
Maybe
in
2 years.
Yeah, version 25. From version 25, they have removed, I guess.
25 is latest one, I think.
No, 26 is the latest.
26. Okay.
They removed in I think 2020.
4.
One, yeah,
4.
something like that.
Yeah.
I mean, year I'm telling.
Yeah, okay. The
Yes.
version is the 24, I think. Okay.
Yeah.
Okay, Raj, can you tell me what is that statement? What statement they stated? Because I'm not remembering. Rajgopal, you are on the mute. Rajgopal, you are on the mute.
Yeah, sorry. Yeah, actually, he's telling something. No, he is telling some query.
He is asking that why that removed, and you are telling that you there stated
Yeah,
one
see, actually,
sentence.
I have read like very long back. I read something like the frictional force. It's already we are feeding input.
Okay.
Yeah, we are feeding, but
Something. Like
it is not
I'm not
conserving.
sure. Like in Monday, I will share the. Monday I will share in the group like what exactly I read and I studied somewhere like regarding this frictional force.
Okay.
Means
And it is
PVLite
included.
they stated.
Why it is not, why it is excluded? They have clearly stated in pvelite.
Oh.
Okay, PVLite they updated in the version, means what are the changes they stated like.
Yes.
Okay. Maybe we have to verify in maybe 24 version or maybe 23 version. If you get,
I will share the condition because it is there in my office in my office system.
okay. Okay, please share. So accordingly, Ramakrishna he'll
Sure.
get updated, and also others also get updated on.
No, in our case, actually, our civil team insisted that it should be taken care. So we have done that manually. I mean, we have done manual calculation. So if it is, I mean, if it is really not required, then it will be. We can do this.
See, but your mu value 0.3 will not give that much of effect. Correct.
No, it depends. No, how much heavy is equipment. No, it does. I mean, we have seen it impacts.
Why this civil they are insisting? Maybe some.
I mean, they say that because of this expansion, thermal expansion. So a force will
where it will expand.
No, I mean the sliding saddle purpose.
My sliding saddle will slide, but it will not. We can't even imagine how much it is sliding. It is very negligible movement. It will be there.
Yeah, but it is again the depending on the temperature variation, the saddle will slides on that foundation.
Exactly. Even if but now the slider is fixed and sliding saddle, it is used for considering all the horizontal vessel, even though if there is no temperature difference.
Yeah, they will place that one because the summer maybe the temperature rises. Due to that one, they keep sliding one sliding saddle and one is fixed one, like that normally. And the sliding the bolts and that one they will provide means there's some gap in that one, so that it can slide and it can be easily accommodated in that one.
Can I share my screen?
Yeah, you can.
Well, let this be our vessel.
Okay.
Yeah. So let's say this is the fixed saddle which is on the. This is fixed saddle. Okay.
Yeah.
Okay.
This one. Due to the expansion. Okay. Due to the thermal expansion, since this is fixed, we assume that this is fixed.
Okay.
Oh, sorry. This being fixed, so it is allowed to move only in this direction. So this it tries to move in this direction.
Okay.
Right.
Yeah.
So this movement, this has to be.
Your longitudinal force only now will move.
Yeah, that's what. Yeah, the longitudinal. So which
whether it is.
Yeah. So this one, whatever this due to this movement, so you will receive a counter resistance from your.
Yeah, your longitudinal force will give the contraction of the vessel.
Yeah, so this is the resistance by the your foundation.
Exactly.
Yeah, and so to that, adding to that, suppose if you have a wind and seismic movement in this direction, so then it will be added. Actually, this calculation is done in another software by Bentley. I think I forgot the name. So I mean, there they have given clearly when. So with that, yeah, I think it is auto vessel. I think auto pipe vessel. So that
Yeah,
software.
auto pipe. Huh.
Yeah.
Auto
Yeah.
pipe generally it is built by Technip, no?
Yeah. So
Tech-
They
there.
are only using.
Yeah. Yeah.
Bentley, there is one more software there. Auto pipe is there, so it's
Yeah,
included our vessels.
auto pipe it is they, I think they from the Technip internally they have built and they are using by themselves.
No, it is by.
Technip
I
build
don't
is
know.
something.
No. It is by Bentley.
Bentley one it is. Bentley one.
Bentley, not a Technip.
Technip maybe some same name maybe
No,
there.
what I see why the frictional coefficient it is removed. I believe is in pvelite pvelite is taking maximum of wind load frictional force along your x direction. Okay, I mean in the longitudinal direction.
Yeah.
That maximum of wind and the frictional force which is taking your vertical load to calculate the vertical load. So in that case your coefficient will be 1. Hence it is removed. So correct, no? Yeah, this is what I read. I remember.
No, I think it is not correct.
Wind and that one it's
No,
not
actually,
comes.
see,
No, here
your main concept was the saddle is creating due to your foundation, correct? Foundation load.
Yeah. Yes.
Your foundation load is nothing but the combination of wind, seismic, and the frictional forces.
yeah, but here we are considering for sliding one. Sliding one comes for heat transfer. When you heat transfers is more, then it slides on that one. So on that case, they have to.
Yeah, it's nothing. Yeah, that is what I'm saying. Your maximum load is your load of wind and your load of frictional force at the x direction. I mean, in the longitudinal direction is higher, no?
Yeah.
1 second. I think there is a video also. Maybe let me share that link to you. I think they clearly explain. I think. I mean, I am unable to explain, but okay. Let me share that link to you. Maybe please go through. Maybe next week we can discuss again.
Sure. Definitely. In the meantime, I will also share the document which I studied.
Yeah.
Okay. Why they removed that one and that one?
Yeah.
I mean,
When we had I was there in Kuwait when this incident happened, and there was a pvelite webinar also happened why they removed the frictional version. And I believe now they are doing some webinar, tomorrow in this week.
They're different places. They do different timing. I don't
No,
know.
webinar is in online, no.
Okay, online webinar they're doing. They send only the particular.
Yesterday I got a notification from the pvelite. There is some webinar. If anyone is having license pvelite, they can open and see the news feed.
Okay. So, but they actually whatever updates, the recent updates they will update, means they will inform or they will discuss in this webinar. The last maybe the previous one they may not inform or update.
No, I believe this is for some topic. But if we ask some query, they will respond. No.
Yeah, they will respond that one.
I shared that video link. You may go through. So we will discuss next week. Yeah.
Sure, definitely.
Also, he's sharing that one. Maybe what is the updates in the pvelite, why they removed that one. If he get, he can share that one. So we will also go through your video also. We'll see that what we can.
I mean, we
where
cannot trust
where you are
100% pvelite. We cannot trust 100%. That's
from Europe, in European standard, like EU code now, we are doing 33 to 33 equipment.
Oh, okay.
Yeah, 22 design and quantity is 33, which is like European standard.
Uh,
EN 13445.
Yeah, 13445.
part 3, I think, no?
Yeah, part 3 for design.
Part 3 for
fabric.
design and for others for the material inspection, etc.
Yeah, material inspection. Yeah, it's almost equal to ASME, but some contradictions are there.
No. Allowable stress is slightly more.
Yeah, factor of safety is different. Yeah.
Yeah, different.
And it is like they are, it is CE marking is there, and due to CE marking, notified body again HSP comes under the picture, and they are literally fucking us like anything. This welding configuration, it is not in the code, it is there, so on, so. And many FEA we did. There are so many bins we are doing here, and reactors also we are doing. And some of the configuration is very critical, and it is not listed in the EN standard. But it is there in the ASME.
So you also do FE also?
Material you are using ASM metals only?
No, EN standard. 355 NL1.
335. Yeah,
355 NL1.
GH something.
Yeah, this 355 NL1 is nothing but SA 537 class 1 material.
Yeah.
Low temperature material.
You can use metals also.
Yeah, we can use any material, but we have to like submit one for like document to
PSC. They call it.
One PME. Document is there.
PME.
PMA. Yeah. Positive material.
Particular material appraiser.
Particular material appraisal. Yeah. But our client intentionally they asked EN standard material only.
Okay.
And we got material from Europe. Like it was very difficult to get also.
I have done for I think not now. I think maybe 5-6 years back. All ASME material. Most of them stainless steel.
Yeah.
Now
we are using like many things. Very huge thickness we are doing, like 90 mm thickness it was there.
Oh, good.
90 mm in SS? Or CS?
No, 90 mm in CS.
Okay, CS material. Okay, CS.
It is LTCS, like nothing but like low temperature carbon steels.
Okay. And so it's using for low temperature services.
Yeah.
Grade 60 or even
No, EN only.
Okay.
It is 355 NL1 only.
NL, yeah.
Okay. So it's equivalent to grade 60, right?
No, I think it is.
No, actually, three class 1 and class 2. Yeah, 275 one material is P275 NL1 is there, and it is referring to 516 grade 60 and 70.
Okay.
Yeah, it is equivalent like.
Okay. So you are not using that.
355 is your yield actually. 355 is your yield, and 275 is your yield. Like that, it is saying in the EN standard.
So they clearly segregated for LTSA and this one.
In ASME, it like their pronunciation, like their material description is different, and here in EN material description is different. Nothing else.
Yeah, like we have part 2, so like that EN 4345, there will be, I think, some parts will be there. So in that, all the metals are listed. So you can.
Let's study exactly.
Yes.
Okay, Ramakrishna, any other point you want to discuss?
No. Yeah.
Okay, Rajgokul, you have any points to discuss?
No, actually no. If anything is there, we'll let you know.
You are doing 30-35 equipments and you didn't facing any issues or anything in that one?
No, almost we have completed. We are in the final stage of like projects. Yeah.
In that one, any tanks also there in your equipments? 35.
No. Tank, in Fabtech tank, they are having separate team. Like we are like dealing with only pressure vessels and heat exchangers.
Okay. So any of your pressure vessel, any supports has come on the dish side rather than on the shell?
Yeah, leg support is there, no?
Leg support is for horizontal. I'm asking horizontal for this saddle support. Some whether you support it anytime on this.
In horizontal vessel?
Yeah.
No.
Okay.
No, horizontal vessel, how it will hold?
Yeah.
I have supported in cone.
Okay. If you support it on the cone, then how the analysis on that one you done on that one in cone supported?
Come again?
If you supported
That will
saddles on the
accept that,
cone.
sir. pvelite accepts.
No, yes.
In pvelite we can do it.
Yeah, we can do it with the cone, no?
Directly.
It is directly on the cone, yeah. Pvelite accepts, yeah.
Okay, directly you will support, means one shell is there, middle, and then next, instead of dish, there is a cone is there. On that cone, you are putting the saddles, right?
Yeah, yes.
Okay, so
See,
directly.
in bins, now we are doing bins. Bins, what will happen? That in top there is a dish, then shell, then there will be a longer cone. Then the cone will be connected to your flange.
Okay.
So your support will be on the cone only. You don't have any other option to give for transportation.
Okay. Then these saddles are for transportation you designed. It's not for service you designed.
No, not for service.
Okay. So any service did you design for?
Service, no.
Okay. So you have columns also, no, in yours?
Yes. Columns also.
Okay. So what are the major points you have to consider in the column designing and that one?
Major points in the sense?
Like
what all we are taking care like that?
Yeah. What are the care need to be taken in the designing?
We have to make sure your wind there will be any wind deflection when you are designing the column.
How much it is allowed?
200 mm.
Okay, maximum is 200. Whatever the size, whatever the length will be there.
Yeah.
1 by 200.
1 by 200.
1 by 200.
Yeah, 1 by 200. Yeah. More, let us say 200 mm.
Okay. So whatever the length will be, the 200 mm deflection is allowed. Okay.
Yeah, deflection will be allowed. So
No,
see, if main thing is if your diameter is lesser and your TL to TL length is increased, then it will come under the picture.
Okay.
Let us say your diameter is 2 meter and your length is 30 meter, then it will come under the picture.
Okay. In that condition, what precaution you will take?
No other option to increase the shell thickness.
But last time what we discussed, we provided some guy wires in that one to support that one, to not to deflect in that one, right, Ramakrishna?
What you'll do?
Not guy wires actually. It is guide supports.
Guide support.
See, your in long column guide support will not a good option because we also.
Wherever there is a feasibility, there only.
Yeah. See, unless otherwise, if there is no platform, you cannot give the guide support, right?
Yes. Sometimes if the diameter is very small, like maybe 300 mm, 400 mm, that size only, and it is very, very long. So you cannot design a self-supported column. In that case, structure becomes mandatory.
Yeah, actually, what happened in that case? See, as we are a design engineer in the fabrication company, we doesn't know platform in the initial stages.
No, I mean generally.
So in that case, you cannot like a quote also. Without knowing the
5 meter gap will be one platform normally.
Generally, the people who does the feed, they will come to know. So I mean, if it is a professional company, they will generally decide.
Decided normally the
Exactly,
gap
exactly.
one platform to others will be 5 meters, and
See,
depending on the nozzles available.
in the estimation stage, what we advise our estimation team is to consider if there is a column which is greater than 8 to 10 meter of height, consider two platform less than 15 meter. In greater than 15 meter, every shell core consider one column. Sorry, one platform.
Every shell course it's a 1.5
No, no, no.
meter.
Platforms is different, no? So that is anyway. We are not talking about platforms. We are talking about guide supported columns.
Yeah.
Both are different.
Guide supports which supporting the column to not to deflect, and platform where we stand and will work and will what will do. That's platform. This actually.
Okay.
And this platform normally means whatever we work project, they normally provide a gap between 5 meters one platform to other, and one shell to other shell means it's normally one shell normally width is 2 meter. So
Yeah, 3 meter we can like even 3.5 meter also
yeah,
we
that
can
special
consider
case we have to order special plates.
if you are
Yeah.
procuring from mill.
Yes, from mill we are considering then 3 meters we have to add or order. But normal case is 2.5 or 2 meters normally we'll add 2.5. So 2.5 one shell to other shell. So one shell to other shell normally we'll provide 5 means 2 shells gap normally we'll provide.
If you are having any any model like how the gate support will act, no, just share it with us. Like we will also like it will be very helpful for us also.
Yeah, last time what we discussed, we actually made that one. I will Monday I will share that one, the links and that one. So you will
No
get to know
issues.
that. Okay. Any other points you want to highlight in the column design or any other?
Yeah, in column design mostly we will take like four major points. One is this wind. Second one is like combined loading.
Okay.
Due to, and the third one will be the rigging.
Okay.
See, sometimes you considering your lifting, your thickness may increase.
Okay.
By locating a trunnion, it is very very hard if your column is more than 50 meters.
Okay. So rigging analysis is important and the deflection important and
Rigging. See, people will not in estimation stage. Many people will not consider the trunnion exactly in the position. While doing the detail engineering, rigging will play a major role, and your unity will not be less than one always.
yeah, but wherever we place this trunnion supports, there if we provide some thickness, we increase and that one it will take care, I think.
No, it is not that kind of like structure. If your unity is failing, from the bottom only you need to increase the thickness. But it will not it will not be useful if you are increasing the thickness where there is a lifting trunnion is located.
Okay, so from bottom you have to increase
From
the
the
thickness.
bottom, yeah, from the bottom of the decision, from the bottom decision, you have to keep on increasing the thickness and check whether your unity is satisfied or not.
Then again your weight will increase and everything again.
Weight will increase again. Your trunnion will increase again. So, like in some point, you will finalize the thickness.
Okay.
Yeah. If you are see your combined loading, your rigging, and your wind deflection, your vertex shading, it's all comes in the one picture to increase the thickness and weight.
Yeah, if you increase thickness, the weight will increase.
Yeah. So this all like interrelated with each other when you are designing a column.
So instead of inside pressure and that one, the more thickness will come by this rigging and this analysis. Right?
Exactly. Uh, we have designed 100 meter vessel.
Okay, 100-meter height.
When I left, when I left that revision 0 calculation I submitted and I left.
Okay.
And that is
Okay, complete.
2,200 metric ton it was.
Oh, very big one.
Your lifting weight, you will not believe.
Where it
And
is?
another one project, another one job, 13-meter diameter,
Okay.
and there is one shell course which is coming very closer to the next to the cone, and there is one process nozzle which is having 48-inch diameter.
Okay.
Yeah, when you are limiting when you are limiting, no, your shell ID is 8.2 meter. When you are limiting the diameter of the nozzle, your thickness is increased to 240 mm. And we got a forged shell in that position, in that area.
Means you are
And that
limiting nozzle, so due to that one, the shell thickness is increased. I didn't get how it
the
is.
shell thickness increased, and it is increased to 240 mm. We got the forged shell, 8.2 meter forged shell. You'll not believe.
Okay, due to the loads coming on that nozzle, the
Yeah,
thickness.
loads coming on the nozzle, exactly.
Okay, okay. So due to that one, it's increased. So you bought the shell also with forged and the nozzle also with forged, right?
Yeah, exactly. And your bottom shell course is 13 meter, then cone, your top shell course is 8.2 meter, and to overall height is 70 meter, and the total weight is 1,890 metric ton.
Oh, this vessel one, huge one it is. Okay.
Like it is like a milestone project when I was there in Israel.
So you submitted first revision of this document, then further the thickness is increased or
No. Further thickness not increased. Then I left from the company.
but they might be revision 2, revision 3, then not updated any thickness, anything.
No, thickness will not change. No, we have ordered all the material. No. When you are submitting revision 0 drawing, immediately you will order the material.
Yeah, but first revision they will not come if they not comment on the thickness or maybe the pressure or something inside. So the thickness will not change.
Actually, this was a critical equipment, no? So we have finalized everything.
Okay. So you finalized and you left. But then good achievement.
Yeah. We have finalized most of the issues.
Good achievement.
Hello.
Yes, Atul.
I have to design 20 to 25 heat exchangers for as per CE certification, like PD 55A, PD 5500. So which factor which I have to consider during design for material and anything?
No, which materials you are using? I mean, which standard materials you are using? I'm sorry.
Material they said you have to select it at your end.
So if directly European, I mean the materials which is given in the code PD 5500, I think then it is easy. Otherwise, if you are using other than those mentioned in the code, then you have to follow you need to make a document called particular.
Ramakrishna ji,
Yes.
Ramakrishna, sorry to interrupt you.
Yes.
Like I'm having some work, so I'm taking a leave.
Yeah. Okay.
If anything is there, you just please share in the group. And my manager is also there in the group.
Okay.
Is it okay to keep your manager in the group or you want to remove him?
No problem.
No problem. Okay.
No issues. What you will do? Nothing.
Yeah, nothing but if you raise any queries and then he might come to know that okay, he's also having some issues.
No problem. Nothing will happen.
Okay.
Apart from this knowledge, we will not raise anything. No. We are not going to design anything in this company.
Yeah. But actually, we kept the managers and that one also because at least they come to know that our engineers also know, means our juniors, they know the things then. They are when you answer the queries and that one, no, they also get aware that okay, he knows the many things like that because it's not.
See, that's what we are here in this company.
Yeah, we are here. But also, if you are answering, then they also come to know that okay, he's supporting some others also. It's not only our company.
No, nothing like that. Nothing like he's very good. He will not mind anything.
Okay. Then
unless otherwise we are sharing the internal details, he will not mind.
Okay, we are not sharing any internal details on that one. Even when we record this one, no, we will remove the company's name and that one in our recording, and company name, any
No,
official names.
not nothing.
Okay, okay, okay. We'll keep him. Not issue.
No.
Okay, Atul, yours issue you want to use metal, right? In PD55. So
Yeah, see
PD50.
but which material specification I have to follow?
Yeah, material specific. It's in their data sheet. If they mentioned in like follow the, because PD55, it's again it's a BS standard.
Yeah,
So
British code.
yeah, so this is if you follow what you are they given that one. So in data sheet the material what the BS standard what are given material. So you can follow that material. Else ASME if you follow and get approved also it's a not issue. So the material whatever you following just refer that PD55 what material they are mentioning. So you can follow directly that one, or you can follow ASME also and get, because this PD55 equivalent material in ASME is available. So same you can follow.
Okay, okay,
Yeah,
got
so
it.
if you are using materials other than those given in a PD 5500, then you need to make a document called particular material appraisal.
Yeah,
So
TDS
that,
type.
yeah, it's called
Technical material sheet.
it's called PME. So
Hmm.
where the I mean where you need to list the what are the minimum yield strength and the mechanical properties, elongation limits, all those things, and that you need to submit to your AI, your third party,
Yeah,
and they'll approve. I think you need to make some sample testing also. So
yeah. Yeah, sure.
yeah, yeah. So I think once AI approves it, you can use it.
Okay.
Yeah.
Just make the list of that one material which are using and send to them.
Yeah.
So these are the material we are going to use for
Yeah.
designing. So if they approves, then you can continue. Else, ask them which material we need to use, because this
Yeah,
standards not says that you have to use BS only. You have to use ASME only. So it's up to you.
yeah. It is same like if we use HM material and it is not listed in ASME, we conflict the two material and show it is good and it is in pvelite also.
Yeah. Also, before that, also in PED, just go through that PED. There is a PED process equipment directive. One document
Hmm.
will be there. It will be like hardly 20-30 pages. Okay.
Ah,
So
yeah,
yeah, please go through it. So in that they will give they given a criteria of some categories are there. Category 1, 2, 3, 4. Uh,
yeah. Hmm.
so that categories you need to find out. I mean, depending on the nature of the fluid and the pressure and volume multiplication, that some criteria will be there. Based on that, if it is category 1, I believe, I think you need not do the certification. So such things are there. Just go through that also.
Okay, okay. It's like inspection category. Okay.
Yeah. So I think if it is it is not stringent, then I think it will be easy for you. So, I mean,
Yeah, yeah. Sure.
you don't need a certification at all. I mean, so
Okay.
yeah, such thing is there. Just go through it. Yeah.
Okay, okay.
PD actually it is a guidance to your which are the materials or which are designed to use by using PD55 or like that. So just it is
So
guidance.
any European code. I mean, this PED is for any European code. I think even we can use ASME also. I think to get the CE marking.
Yeah, but it's given just guidance. It's not code or anything. Authorization we can get from them. Just it's a like,
No. I think PED is the basic document, no.
yeah, basic
So
document. It's just a
yeah, that is. I mean, the work starts from that only. From that, the categories are established.
yeah.
So
In Dennis Mouse also they given in the last where material they specified. They mentioned when temperature is like which fluid you are using, then which material to be selected like that also. In Dennis Mouse also is given like in area
yeah.
also.
So it's called PED means it is Process Equipment Directive.
Yeah.
It is a legal document for European Union. Maybe you can download from internet.
Yeah, it's also used in like a package material.
maybe, yeah, I don't know. What do you mean by package material? I'm not understanding, but yeah.
Package material normally it's Atul, you mean that it's consist of two or three equipment in the skid or like that?
Yeah, skid, like a skid.
Okay. So in skid also there may be some heat exchanger also there, some vessels also there, there might be some pumps also there, and these are connected in the piping and that one. And there also you can use that one. This guidance is given for our vessel, means if you are referring the vessel PD, then you will get the guidance on the our vessel
Yeah,
related.
one more question I have. There is a condition. One vessel is designed by EIL, and the scenario is after bidding and won the bid, they provided us platform and ladder drawing, and they designed 4 ladder in a single vessel.
Okay.
So is it okay? And the ladder is not entering with the platform side also. It is like loose.
I mean, can you draw a sketch? And we are not understanding actually. So scenario. Can you make some kind of hand sketch?
Right now, I did not have any sketch, but I will share all my drawing in the group also on Monday.
Means you are telling there is a vessel, horizontal
Platform,
vessel.
if we see from top view, there is a normal vessel, horizontal normal vessel.
Yeah,
if
normal
we see on
vessel.
top view,
Yeah.
then if we see top view, left hand side is platform.
Okay.
There is 2 ladders coming to opening with the platform, and there is 2 ladder also. They mentioned in right side also. There is no platform.
Okay. So on shell there are 4 ladders are there.
The shell is there, but ladder distance they have mentioned 5 meter, and vessel is just 2 meter.
No, actually, this ladder and platform is generally piping business. I think static engineers should not go into that. I mean, it will be decided by the piping layout guy. So I think it may be required as per their plant layout.
Actually, piping also it depends. If it is connected to vessel, then vessel person will decide depending on the nozzles coming and that one. And
Yeah, that's right.
Yeah,
yeah.
But basically, the how much is the extent of the platform and how many ladders should be at what elevation it should be. That will be decided by piping guy. Maybe you can ask. I mean, you can raise a query. So I mean, yeah, always static guy can ask. So why it's
yeah,
like this? Yeah.
yeah. I asked with, but engineers in Delmeter did not reply as soon.
Yeah, this ladders and this one normally comes where there is some nozzles, means instrument nozzles are there where you want to climb and you have to check the readings and that one. So there, depending on where nearby nozzles or you have some maintenance on, maybe the platform is, maybe the manual is there, there's something you want to open. So there accordingly that ladders and that it comes, ladders and platform.
Okay,
So
got it.
easily access your nozzles or water instruments and water pipings that's coming, no, they're connected to your vessel. So to access that one, this normally comes. So
Yeah.
check with your piping means who are involved in that one. So just along with him, you can decide where to keep, because
Yeah,
you.
they
Try
mentioned
to,
ladder.
yeah, you can ask the model. I mean, if they can give you the model, maybe you will understand better. So why it is.
Yeah, sure. Yeah, I have to do this. Okay.
Okay. Any more?
Yeah, that's it. Yeah,
Okay, Ramakrishna. Atul.
yeah. Thank you.
Anshul, I think you are on the mute only today. You don't have anything. I think you are traveling or you are outside. So you told that you just may not be able to answer. So okay, then can we
Yeah,
wind it
yeah.
up? Okay.
Thank you.
Okay. Thank you. Bye. Good day.
Bye.